All right, continuing with problem number 3. It says the pizza can be eaten once its temperature drops to 45 degrees Celsius. Letter E says calculate to the nearest second the time since the pizza was taken out of the oven until it can be eaten. So now they give us a temperature and they want us to figure out the time it takes to get to that to the nearest second. So I'd plug this in for P of T and then I would solve for T. So if I plug it in, I'm going to have 45 equals 211 times 2.06 to the negative T power plus 19. All right, so now this turns into an algebraic problem. I need to solve for T. So I'm first going to subtract 19 from both sides. So I get 26 equals 211 times 2.06 to the negative T. I can then divide both sides by 211. Instead of doing that on my calculator, I'm just going to leave it as a fraction for now. So I would have 26 over 211 equals 2.06 to the negative T power. So now, just like problem number 2, we have an exponent or a variable in the exponent. And how we can get rid of that is by using logarithms. So I can take the log base of 2.06 of 26 over 211 to get the T out of the exponent. So that's going to equal negative T. So if I type that into my calculator, and again, how to get to logarithms, go to the math button, go up or down to letter A. So we're doing log base of 2.06 of the fraction 26 over 211. If I round that to 3 sig figs, I get negative 2.90. And again, since it's a negative T, if we divide both sides by negative 1, T equals 2.90. Now, remember, if I go back up to the directions, it says that T is time in minutes, but they want us to say our answer to the nearest second. So they're trying to trick us here. This is not our final answer. This is 2.9 minutes. So finally, what I would do is multiply 2.9 by 60, obviously because there's 60 seconds in a minute, and we would get an answer of 174 seconds. So almost 3 minutes. Finally, the last part, part F, in the context of this model, state what the value of 19 represents. Okay, 19 is right here in our equation. And again, if you think back to example number 2, talking about the temperature of the boiling water in the cup, that constant number in the terms of this temperature problem represents the room temperature. So in the context of this problem, it is the room temperature of the dining room. That dining room is where they put the pizza after it's taken out of the oven. So it can never get below that room temperature.